Okay, let's go ahead and go over our last practice worksheet. So, number one, Sam is driving along the highway towards St. John. He travels 150 kilometers in 3 hours. What is his average speed for this trip in kilometers per hour? Okay, so let's answer this first part. Let's go ahead and write out our givens. So he travels 150 kilometers. So kilometers, that's a measurement of length. So I know my x is 150 kilometers. Then I also see 3 hours. So hours is a measurement of time. So time is 3 hours. Average speed. So I'm just looking for my average speed, which is just going to be v equals x divided by t. So when I go to plug that in, 150 divided by 3, and then kilometers. So that's going to give me 50 kilometers per hour. So that's part A. Part B, what is his average speed in meters per second? So then I've got to convert from kilometers per hour to meters per second. So I know that there are 1,000 meters in 1 kilometer. I put kilometers on bottom to cancel those out. Okay, so now I've got meters on top, which is what I want. Then I got to convert my hours to seconds. I know that in 1 hour there are 3,600 seconds. And I get that by multiplying 60 seconds times 60 minutes, and that is going to tell you how many seconds are in an hour. So then all that's left is to complete the math. So I've got 50, 1,000's on top, so I'm going to multiply by 1,000, and then I'm going to divide by 3,600 since it's on bottom. And I get an answer of 13.88, so I'm going to round up to 8.9 meters per second. Number 2, a vehicle travels 2,345 meters west in 315 seconds toward the evening sun. All right, evening sun, the sun sets in the west, so I also know that he's traveling west. All right, so what's the average velocity? So I saw that x distance, meters, all right, meters measures distance, so the distance that I traveled was 2,345 meters. My time was 315 seconds. All right, and technically this is displacement since we know that it's west. All right, so what's his average velocity? Well, velocity is equal to displacement divided by time. So we went 2,345 meters west in 315 seconds. So now I'm just going to do the math. 2,345 divided by 315 equals a velocity of 7.44 meters per second. And since this is velocity, we need a direction. What direction were we traveling? We were traveling towards the setting sun, so we were traveling west. Okay, what distance? So I know already that I'm going to be looking for x. Traveling 18 meters per second. Meters per second is a measurement of speed, so we know speed is 18 meters per second. Covers in 3 hours. My time is 3 hours. Okay, so what distance? Well, first off, I notice that my time units are not the same. So in speed, you notice it was measured in seconds, but in time we were given hours. So what are we going to have to do? We're going to have to convert our hours to seconds. So go ahead and we already know that in 1 hour there are 3,600 seconds. So all I have to do is multiply 3 times 3,600, so 3 times 3,600, and that gives me 10,800 seconds. Now all that's left is to solve. So I know the triangle is v, x, and t. What am I looking for? I'm looking for x. So that tells me to rearrange the equation. X equals, they're on the same level, v times t. So X is equal to, my v was 18, my t was 10,800 seconds. So I traveled 18 times 10,800. I traveled 194,400 meters. Final answer. And we don't need a direction because we're talking about distance. Distance is a scalar, doesn't need direction. All right, number 4. How long will it take to go 150 kilometers east, traveling at 50 kilometers per hour east? All right, so the first thing, I see 150 kilometers east. I see a direction, so that means I'm dealing with displacement of 150 kilometers east. I see kilometers per hour. That is a unit of speed. Then I see direction, so I'm dealing with velocity. So my velocity in this case is 50 kilometers per hour east. What am I looking for? How long? How long is another way of saying how much time did it take. So if I scroll back up here to the triangle v, x, and t. What am I looking for? I'm looking for time, so that tells me to divide my x by my v. So time is equal to x over v. Plug it in. We've got 150 divided by 50. All right, and that should be pretty easy. 150 divided by 50 is just 3. What time unit did we use? We used hour. All right, so it should tell us that it's 3 hours. And time is a scalar. It's never going to have direction. It only moves in one direction, so 3 hours. All right, and last, our bonus. Draw a picture of the system and create a coordinate axis to help solve the problem. A soccer ball is kicked 25 meters east, then 15 meters east, 8 meters west, and then finally 12 meters east. All this took place in 45 seconds. Calculate the average speed and velocity of the ball. All right. Well, in order to calculate the average speed, the two things we need are x, which is distance, and we need t. And then for velocity, we need the displacement and time. So create a coordinate axis. You can also call it a number line. So let me go ahead and create a number line here. We'll put 0 here in the middle. Soccer ball is kicked 25 meters east. Well, normally east is to the right, so I'll go ahead and 5, 10, 15, 20, 25. So 5, 10, 15, 20, 25. So it started out here, and it went to here. Right. Then is kicked another 15 meters east, so 30, 35, 40. Okay, so now it went from 25 to 40. Then 8 meters west, so our next movement was 8 meters west, so in the opposite direction, so that now we're going left. So now we end up at, looks like 32. And then finally another 12 meters east. All right, so now we go another 12 meters east, landing us at 44. So that if that was 45, we would land at 44. All right, so next thing is to figure out, okay, what is the total distance? Well, total distance doesn't care about direction, so we just need to add them all up. So 25 plus 15 is 40. Plus 8 is 48, plus 12 is 60. So our x in this case is 60 meters. Time, which was given to us as 45 seconds. Now we got to figure out, okay, what was our total displacement? Okay, what was our final? What was our initial? So displacement is equal to final position minus initial position. we look at our number line, we ended at 44 meters. Okay, so our final was 44 meters. Our initial was 0. So that makes this easy. So our displacement is 44 meters. And then what direction? Well, we ended up going to the right, so that's, in this case, east. And then time is the same, 45 seconds. And so now we have all that we need. Speed is equal to x over t. Our x was 60. Our t is 45. So our speed, in this case, once again, scalar, not needing direction, 60 divided by 45 is 1.3 meters per second. Then velocity is equal to displacement over time. We found our displacement to be 44 meters east, and then taking place in 45 seconds. So therefore we get 44 divided by 45, which is 0.977. So if you want to put 0.978, that's fine. Or you can leave it as 0.97 meters per second. And which direction did we travel? We traveled east.